So when it was the first indication of Parkinson's? It's actually 20 to 30 years before indigestion. That's the commonality. And then it starts to, as it progresses, there are other symptomologies that begin to happen. Significant slowing of the heart, but that's usually insidious, so we don't even know. It's just slow going, so we never realize that our heart's not functioning nearly as well. And when we have the digestive issues, we're going to start having issues along with it over time of erectile dysfunction. Then it's going to travel up into the cranial nerve 10 and also then cranial nerve 1, which means we're going to eventually lose sense of smell. And so that means we're going to lose sense of taste. And so that's one of the things that happens before the actual tremor that happens, the pill rolling tremor. And that is just an inability to gate the flexor extensor system. That's what this is. Flexor extensor, flexor extensor, flexor extensor. And so that is the progression. By the time you get this, you've lost 70% of the substantia nigra, which is the area that's dying in the brainstem, but the cortex is dying too. And what's interesting to note is when you look at Alzheimer's, when you look at dementia, and you tend to compare those, you don't tend to think of Parkinson's in that same category. It's a brain degenerative disorder, but it's got a movement disorder inside of it. And so when we compare these things, there are commonalities within all of those. The Alzheimer's, dementia, which is frontotemporal demise, Parkinson's, supranuclear palsy, and there are others, in that category. Multiple systems atrophy. Those are all one big category of brain degenerative disorders. And so they all have a commonality. The thing that's different is what's going on within the cells as they degenerate. As they degenerate, there are different kinds of proteins that they're having problems with. They getting rid of proteins that are misfolding due to free radicals, and that's an entire system that's different from a genetic point of view. When you have the synuclear protein that gets hit and it misfolds, as it misfolds, it's a part of the microtubule system that moves stuff down the line within the cell, and then you've got enzymes in there that are to unfold the misfolded protein. And you also have, let's say I can't unfold it, I have an apoptotic system that's supposed to break it down. But let's say both of those are a problem for you genetically. You've got very weak, ineffective unfolders and weak apoptotic system. Now your cell is breaking up internally and you can't undo what's going on. And so now I've got all this cellular junk besides the cell is breaking down. That's the disease, brain degenerative disease. Brain degenerative disorder is different. It's a, if you don't use it, you lose it proposition. And most people are having that issue. Why? Because there are parts of their brain they aren't using anymore. And if you don't use it, you lose it. And so, but the difficult thing in brain degenerative diseases are, as those areas start to have issue, as the cells begin to break down internally, they stop doing their job as well. And so because we're not using it, we lose it. That causes the brain degenerative disorder. If you don't use it, you lose it. So it's a double whammy. Whenever you have a disease, the brain degenerative disease, you're going to have also the brain degenerative disorder. And that's why when my first priorities are turn that system on as high as I can so that we don't have the brain degenerative disorder, and then we can start dealing with the brain degenerative disease in that. And so that when we look at brain degenerative disorders, that is the commonality in all of it. We're always looking for little things, copper and other stuff, to trigger that stuff. But the real issues start so much further down the road, a long time ago, 20 years ago. Okay? I hope that answers